So we continue with the example here for this, this video, and we continue with the example. So let's say you have, okay, the question asks you to determine the Fourier series, okay, for f(x) equal to negative x, and then the interval, it give you the interval here, is from -1 to 1, okay? So this is the interval, alright? And then, okay, they have another one extra equation here, okay? So class, this is not your function, this one. This is not your function. The function that you will be considered is this one, f(x) equal to negative x. Right? This one is what the objective of, what the purpose of this equation. Okay, the purpose of this equation, okay, you can see that they have x plus 2, okay? Alright, so class, actually, x or t lah, okay? If you x and small t is this, what you call the same meaning, ataupun it just use a different alphabet, but it's still the same function lah, ataupun yeah, we can use any alphabet. But the t here, the biggest t here is represent 2. Okay, you can see 2 here is represent t. And what is t? T is equal to period. And what is, if you still remember, I show you in the previous video, t is equal to 2l. Okay, 2l. So therefore, from this information, from this equation actually, okay, because of this equation actually is an information for you to get the value of t. So this is 2, your t is 2, and then 2l. So what's about how to get your l? So you just bring these 2 to this side, so your l is equal to 1. So this is the one way to find your l. Okay, this is one way to find your l by using this by using this equation lah. Or you just can get your l from here, because this is negative l x l. So therefore your l is equal to 1. Okay, sama lah. So this is the second way lah. Okay, so means that yeah, that's what I want to say here is l memang akan diberi lah. So it will be given to you, but how it will be given? Either this way by using interval, or this way by using period. Okay, so maksudnya dalam ada dua cara ataupun dua kaedah untuk dapatkan l. But this one the simplest one lah kan, dan terus tengok, oh okay, ni l. Right, so back to your function here, negative x. So first step, what we need to do is you need to identify first whether your function is odd, even, or neither. So how? They have two ways, okay, to approach. Whether you use a equation or you use a graphical, is it? So yeah, it's simplest one. So we use what you call equation. So we start with negative x. So means that you will substitute negative x into the x. Okay, this is your equation. Okay, I just write back here. So now we want to change, ataupun kita akan tukar lah, kita akan tulis negative x. Okay, so negative here, okay, negative here is this one, okay, negative here. So x, we instead of x, so now it become negative x. Okay, you kena replace apa yang dalam bracket ni dengan x tadi. So asalnya adalah, okay, negative ni tutup lah, okay, abaikan. Sebab kita bawa, because negative is, yeah, you still need to bring this negative. So to avoid you careless, so I suggest you to close it. Okay, so from x we need to replace with negative x. Okay, so then it will be positive x lah. Okay, positive x, right? Okay, so positive x, so maksudnya kalau you nak relate balik dengan you punya fx, so you punya fx will be, what is your fx tadi? Your fx is negative x, is it? Okay, so therefore it will be, maksudnya negative fx lah, negative fx. Okay, I tak sure you whether you clear or not. Okay, macam ni lah. Okay, padam balik. Okay, kat sini. Negative is outside here, and then negative x, right? Negative x is equal back to your fx. So fx. So you get negative fx. So f negative x is equal to negative fx. So therefore is a odd function. Okay, this is odd function. Alright, this is odd function. So then after you identify it's odd. Okay, so make sure you clear on this part lagi these topics, because if you identify wrongly, it will be affect. It will be affect until the end of your answer, of course. So kalau you salah tentukan dia odd, even or neither, so dia akan affect lah you punya coefficient Fourier semua tu kan. Macam for example, this is odd, but maybe some of you do it, you get even. For example, maybe dia silap, dia dapat even. Then they will be used, kalau even dia akan guna equation ni, which is dia akan cari a0 and an. But supposedly what he or she need to do is odd, just find bn. Okay, so make sure you careful on that one. Alright, okay, so now we go to the next. Okay, so this is we done. So okay, maybe to make it clear, so just write lah, just tulis balik equation you. So means that you need to calculate what? You need to calculate only bn sin n pi x over l dx. Okay, so this is what we need to calculate. The equation lah, okay, the equation. Mana ada dx? Okay, alright. So the purpose or the objective is next is to find what is your bn, and yeah, of course you write your coefficient Fourier, the others two equal to 0. Okay, I suggest you to write this, because sometimes the question akan tanya macam ni, apa what we call Fourier's coefficient apa yang 0, for example lah. Okay, so you need to write this. Okay, alright, so now we want to find bn. How to find bn? Okay, so check, this equation is single or piecewise? It's a single, right? So means that your bn equation will be 2 over l 0l fx sin n pi x over l dx. Okay, kelas kejap. Okay, alright, so 2 over l 0l fx. Okay, so now what the we want to substitute your function, I mean fx, l, so on. So what is your l just now? What is your l? Just now your l here is 1. Okay, your l here is 1. Okay, so 2 over 1. And then integrate 0, 1. Okay, what is your fx? Your fx, you get it from your equation. Okay, the first one here, negative x. Okay, negative x. And then the rest just ni sin n is remain as n pi x. Okay, what is L just now? Is 1. Okay, so simplify lah. I don't want to see over 1 because we know that over 1 is still a number of the, for example, 2 over 1 is equal to 2 kan. So tulis terus lah macam tu. Okay, sin n pi x dx. Alright, so this is the equation that you need to integrate now. Okay, you need to integrate this equation. So class, this one, okay, you can see that they have 2. Okay, I circle it with red color here. They have negative x for this first one, and then they have sin n pi x for the second one. So you can see they have 2x. I just want to highlight here they have 2x. So you need to, okay, for the what you call the differentiation, when we have multiplication between 2x, you need to do 2x mean in term of different term lah. Macam ni negative x, and this is trigonometry, sin and pi x. So it cannot combine. So you need to they have a way lah to find the answer. For differentiation, you have product rule. Okay, you have a product rule. So same goes to integration. Not same goes to, maksudnya bukanlah maksudnya guna product rule juga, but they have another method lah to approach or to solve it. So we call it as we have tabular method. Okay, we have a tabular method, and also we have by part method, and also we have substitution method. Okay, so that one I think you need to recall back lah. Okay, saya tak, because that one is not, that one is a basic maths. You already learned it before, so I don't want to waste a time. I will focus the Fourier series only for this part. Okay, right? So yeah, you need to find out by yourself how to find or how to solve this one. Okay, either using by part. It's not all suitable. Maksudnya bukan semua substitution. They have 3 I think they have 3 or more lah. Substitution by part and then by tabular method. Okay, so tak semua tu boleh jawab. So kalau substitution for this case cannot solve substitution by using cannot solve this one by using substitution. Okay, tak boleh. Kalau tengok pun tak boleh. Substitution must be something yang you let. Okay, bila you let and then when you substitute it, another one will be eliminate. Eliminate tu maksudnya hilang. Tapi kat sini tak boleh. Tak boleh nak buat substitution kat sini. Okay, alright. So I just write the answer after we done the process. So you need to find the process by yourself lah. Ke saya nak kena buat ni? Okay tak? Okay, saya tunjuk. Alright. Okay, I'm using tabular method. Okay, you have D and I. Okay, column D is represent differentiation. Okay, yes, class we are doing it for integration, but we still involve with differentiation here. So they have column D here is differentiation, column I is integration. Okay, then you can see that they have two, right? They have two term, negative x and also sine n pi x. So for D column, you nak letak apa? Maksudnya antara dua ni you nak kena letak apa? Okay, the characteristic for D is you choose the term that when you differentiate either n is end up with 0. Maksudnya bila you differentiate again, lastly dia akan sama dengan kosong. Faham tak? Maksudnya differentiation ni bukan sekali je berlaku, dia akan berulang kali lah. It depends until in the end you will get 0. Okay, contoh let's say you have two. Let's say lah you choose sine n pi x. Let's say you choose sine n pi x. You choose sine n pi x for example. Okay, how when you differentiate sine, okay, you just ignore lah yang belakang you tak apa. When you differentiate sine, what we get? You will get cos, is it? We will get cos. Okay, then after sorry, this one is differentiation. Okay, after you differentiate sine, you get cos. Then you differentiate again because you still have a value. Okay, you kena stop until you reach 0, baru you boleh stop. So selagi tak dapat kosong, you need to differentiate again. So differentiate cos, what we get? Sine n pi x n pi square. Okay, negatif ke? Right, check balik lah. Sine, cos, negative sine. So differentiate sine akan dapat cos, differentiate cos akan dapat negative sine. Okay, then differentiate again sine. Differentiate pula sine tadi, dapat cos. So you can see that you cannot end up with 0. You takkan dapat kosong. Takkan. Because it's a behavior of trigonometry. Sine we get cos. Differentiate cos we get sine. Differentiate sine dapat cos balik. Okay, so dia memang takkan habis dapat kosong. So you choose the wrong term. Tu maksudnya you choose the wrong term. Okay, so therefore definitely the only because they have two only kan. So bila dua je memang kalau dah bukan sine, of course lah another one which is negative x. So for negative x, you differentiate negative x, you will get negative 1. When you differentiate negative 1, what we get? You will get 0. Then you can stop already. So we proceed to next column, integration. So automatically the remaining here is sine n pi x lah. Okay, yang tinggal sine n pi x. So integrate sine n pi x. Integrate sine, you will get negative cos n pi x over n pi. Okay, over n pi because this is integration. Kalau differentiation tadi, yes, n pi tu bawa ke depan. Okay, but now it's integration. Okay, then is it we need to stop here? Okay, no. You will stop until this level. You akan stop dekat kosong ni tadi. Ya, baru you stop. So then you need to integrate again lah. So ni integrate cos, you get sine n pi x. Still you need to do it the same thing. So they have a negative outside here. Okay, so sine n pi x over n square pi square. Okay, n square pi square. Then you stop. So then they have mesti ada sign ataupun tambah tolak. So we start with plus minus plus. So it's already fixed. Plus minus plus. So then you cross multiply. Okay, you will multiply negative x with the negative cos ni, negative 1 with the negative sign. Okay, so what we get here? Okay, just substitute what we have here into your step here. So negative x time here, so you get positive lah, okay? Positive x cos n pi x over n pi. Okay, negative, negative, positive, and then you have positive, so positive. And then next, negative, negative is positive, but you have negative, so minus. Minus sine n pi x over n pi square lah, okay? N square pi square is also equivalent to this one, okay? So you get this one. Okay, don't forget lah, in front of it they have 2, okay? Ada 2 lagi kat depan, okay? Alright class, easy, senang kan? Okay, tak ada pun proses integration, tak ada, ada integration tapi kat sini je. Okay, after you done this part, you just substitute here, okay? Alright, so and then substitute the value 0, 2. So tak ada dah, they have no integration involved here already. Just substitute. We already done the integration here. So now what we do next is just substitute 0, 2 into x, So they have 2 cos 2 n pi, okay, 2 n pi lah, over n pi, minus sine n 2 n pi over n pi square. Okay, close the bracket, and then minus with 0 pula, masukkan kosong. So 0, so habislah. Okay, 0 kat sini, so habislah semua. And then 0 here, minus sine n pi 0. So sine 0 over n pi square. Right, close the bracket. Okay, solve. Okay, so you can see that sine 0. Okay, calculate with your calculator lah. Sine 0, what is your sine 0? Sine 0 is equal to 0. So 0. So nothing. Kat sini tak ada apa-apa. Okay. So you just left with this side. So 2, which is 4. 4 right? Betul tak? Mana tuan 2 ni? Oh, S. Oh, class, sorry. This one is 0, 1 suppose. Okay, my bad. Okay, sorry class. 0, 1, sorry, 0, 1. So therefore, saya tulis lain maaf. Okay, maafkan saya. So there will be 2. Okay, x cos n pi x over n pi minus sine n pi x over n pi square. Okay, 0, 1, okay, 0, 1. So 2, okay, 1 cos n pi over n pi, dah habis. Okay, cos n pi over n pi, and then minus sine n pi over n pi square. Okay, so this is the first one. Minus with 0. Okay, tadi pun kita dah tunjukkan, so kosong lah. Alright, so you just left with this one. Cos n pi over n pi, and then negative sine n pi over. Okay, so class, they have one things that you need to remember. Okay, this one, there's some helpful identities that you need to that we will always using lah for calculating the Fourier coefficient here. So the first one is sine negative x is equal to sine x. Sine negative x is equal to negative sine x. So this one is already proven. Kita dah tunjuk pun yang ni dekat previous chapter. Oh, not previous chapter, last week. Last week punya how to determine the odd even kan. Kita dah tulis. I already show you odd and even sine and cos. Sine and cos. Right. So the second one is cos negative x is equal to cos x. Okay, because the sign is odd, right? So that's why they have negative here. But for cos is a positive, so they have it's just a positive cos lah. Okay, number 3 is sine n pi. Okay, when you get or when you see or when you have this term in your equation, sine n pi is always equal to 0. Always equal to 0. Okay, then for number 4 is cos n pi. Okay, when every time you see cos n pi, what we need to do is you need to replace with this one. Negative 1 power n. Okay, and then for the number 5, when you have sine 2 and pi, when you have this term, sine 2 and pi, is also always equal to 0. And then lastly, cos 2 and pi is always equal to 1. Okay, they have 6 helpful identities that you need to remember, because you will replace this into your equation. So like your equation just now, you can see that you have cos and pi z here. So you need to replace with this -1 power of n. Okay, yang ni je yang replace. Okay, cos n pi. N pi here, the denominator is remain as n pi lah. Okay, then minus, what is your sin n pi? Sin n pi is equal to 0. So therefore, definitely they have habis lah. Okay, even though bawah ni still ada, but when 0 divide by numbers, is always give you a 0, right? Therefore, your final answer here is this one. Okay, so this is your Bn. Okay, your Bn. Bn is equal to 2, and then in the bracket they have -1 power of n pi, and it will what you call your n lah. Okay, you kena tulis lah juga 1, 2, 3 dot dot dot. So means that when every time you get your n value, you just substitute the value n here lah. Okay, so the final answer is f(x) equal to, what is your summation? Okay, summation n1, yeah? What is your Bn? 2 -1 n over n pi, and then sin n pi x over l. So your l is 1, right? So this one. So this is the final answer. Okay, you need to substitute back your Bn into the equation. Okay, it's already 20 minutes. Okay, so class, so this is an example on the odd. Okay, odd. So yeah, I try to do another one example with another 2 example for the even and also for the middle. Okay, alright.